Now let's start talking about lattice enthalpy. We have seen about favorable conditions that are required to form a ionic bond. Now let's talk about little bit about lattice enthalpy. So how to determine lattice enthalpy? That we determine by Born-Haber cycle. Let's look at the Born-Haber cycle. It is interesting. So lattice enthalpy can be calculated by the Born-Haber cycle. So lattice enthalpy can be calculated by Born-Haber cycle. Let's take example of Born-Haber cycle by taking the example of lithium fluoride. As you can see here in the reaction, your lithium, which is in the solid state, reacts with fluorine or half fluorine, which is in the gaseous state, to form lithium fluoride. Let's calculate the calculation of lattice enthalpy. How to calculate? Now, if you see, let's consider this delta FH, okay, is the lattice enthalpy. Now, in order to form lithium fluoride, first your lithium, which is in the solid state, needs to be converted into lithium gas. So when solid gets converted into gas, what you get is the sublimation. So this is the enthalpy of sublimation. Similarly, your fluorine, which is F2 molecule, is already in the gaseous state, which converts by dissociation into a single fluorine atom in the gaseous state. So this is your dissociation enthalpy. Now both are in the gaseous state. Now they are going to go into ionic form. So when lithium goes into ionic form and forms a lithium plus 1 or lithium plus in the gaseous state, we get ionization enthalpy. Similarly, fluorine gains one electron to go into F minus state into gaseous state. We get electron gain enthalpy. And when the both lithium plus 1 and fluorine minus, they combine to form lithium fluoride, there is also internal energy involved. Internal energy is what? Sum of all kinetic energy. So this is how you get all different enthalpies and energies, and when you add them together, you get your lattice enthalpy. That means you have to add all enthalpies and energy together. Now let's look at one more example, that is of magnesium oxide. Now similarly, your magnesium, which is in the solid state, oxygen, which is in the gaseous state, they combine together to form magnesium oxide. So what happens? Let's move ahead and let's see. So this is, let's consider again, is your lattice enthalpy. Similarly, magnesium, which is in the solid state, is going to go into gaseous state. So this goes into gaseous state. So again, sublimation. Now this oxygen, which is in the gaseous state, but it is a molecule, so it will be converted into atom. Again, there will be dissociation. So dissociation enthalpy. Now this gaseous state will go into ionic form. So magnesium, when go into ionic form, it donates one electron. So ionization enthalpy. Oxygen gains electron. So electron gain enthalpy. Similarly, the plus 1, magnesium plus 1 goes into magnesium plus 2. Since there are 2 valence electrons, we have already seen that. Again, ionization enthalpy. Similarly, oxygen gains one more electron to go into O2 minus. Again, electron gain enthalpy. And now they combine together, and now there will be internal energy involved, which is sum of all kinetic energies to give you magnesium oxide. So what will be lattice enthalpy now? Lattice enthalpy again will be total of all the enthalpies and energy combined together. I hope this lattice enthalpy concept is very clear now, and this is what is Born-Haber cycle, and this is how you explain enthalpy and lattice enthalpy via Born-Haber cycle. I hope this is clear now.